All right, so as I was telling Cole, I'm just going to put a little test up maybe later on today, hoping for later today, and then for Unit 4. And it's actually going to cover maybe a little bit more than just Unit 4, but that's kind of why I'm doing this review. I'm trying to cover a lot of the course here, so we'll go through it, and maybe some of this we can work our way through. So after this test, and if you've done the culminating, that's pretty much it. There's not a lot left to the course. If you need extra help, you can always send me a message. I'll probably be online on Monday and Wednesday again next week just to see if anyone needs any help, and I can do some one-on-one examples, but otherwise, it's pretty much it. So this is kind of our last class, I guess. All right, so let's go through some of this here. So, Rutledge Foods Incorporated and Shantz Grocers International both supply high-quality ground pork substitute to local restaurants by the kilogram. You don't even want to know what that is. Okay, so, including delivery fees, the total cost of an order versus the weight of pork substitute purchased is shown below. So we can see that Shantz Grocers is right along here. And let's look at some of the questions we have. So, which statement is not true? Rutledge Foods charges less per kilogram. Less per kilogram. Remember, this is not true. Which one's not true? So if we look at, what is it asking us here? If it's saying less per kilogram, it's asking us about a rate. Like dollars per kilogram. So rate is the same idea as slope, right? So basically it's saying if it charges less per kilogram, it should have a less steep slope. And that is true. It does have a less steep slope than mine, right? Than the Shantz Grocers. So that's true. So it can't be this one. Shantz Grocers flat delivery fee is less than half as much as, I don't know why it says Dakins. So it should say Rutledge. Okay, and that looks to be true too, because we have our initial fee that's there. Halfway would be like right around there. So it is less than half. So that is also true. Rutledge offers free delivery. It does not appear to be true because we can see that there's an initial cost, right? So there, obviously the initial cost is kind of related to the delivery. So that is not true. This is most likely candidate, but let's look at it. Let's look at the last one. For small orders, Shantz Grocers is the wiser choice, right? And so that would be true as well, because basically Shantz Grocers is the cheaper one until that point. Anything more than that, any more kilograms than that, then Rutledge Foods becomes cheaper. So the last one is also true. So that does confirm then that our answer is this one right here. All right. Any questions about that? So you kind of have to talk your way through it, especially with word problems, because it's not just going to be numbers sometimes, and especially if you were to write the EQAO, which you didn't have to. You lucky sons of guns managed to dodge that one. So, yeah. You will see this kind of question, though, in grade 10. All right, let's change this equation into slope-intercept form. So it's one of these four. All right, so we have to rearrange this guy right here. Right now it's in standard form. Right, this is standard form, and we did this in our unit. We went from standard form, and we need to get to slope-intercept form. Okay, so we're going to rearrange this equation. So I'm going to rewrite it out here. 3x minus 2y plus 12 is equal to 0. And I eventually want this to be in a y equals kind of situation, right? So I want to get y all by itself. So I am going to move stuff around. So I want to get rid of this 3x. So I will subtract 3x. And I want to get rid of this 12. So I'm going to subtract 12. And whatever I do to one side, I must do to the other side. So I'm going to do that. And then these will cancel out. So my next line would look like this. Negative 2y equals negative 3x minus 12. All right, now I have to get rid of that negative 2. I don't want it there. That's attached to the y because we shouldn't have a coefficient there. So we will divide everything by negative 2. So whatever, like just as before, whatever we did to one side, we must do to the other. So we are left with y equals, and negative 3 over negative 2, well, that's just going to be positive. So I'll get rid of those two negatives and I'll go like this, 3 over 2x. And negative 12 divided by negative 2, again, two negatives, so we get positive. 12 divided by 2 is 6, so we go plus 6. And there is our answer. And then we go back, take a look, see if we can find it. 3 over 2 plus 6, there it is. So you'll definitely see a question like this on the test. All right, which linear equation below would represent a line perpendicular to the line, let's rewrite this, y equals 3 over 7x minus 2. So perpendicular, that means 90-degree angle, right? And every time we do perpendicular, we had to do this thing called the negative reciprocal. And we're only doing this for the slope. So the slope needs to change. So if we find the slope on here in our equation, that's this part here, 3 over 7. So if we did 3 over 7 as a negative reciprocal, 3 over 7 becomes, we flip it, 7 over 3, and we put a negative and change the sign. Flip it and change the sign. That's what negative reciprocal means. So this is the slope we're looking for. Any equation with negative 7 over 3 as a slope. And if we look at them all, there is only one. Right there. All right, so that's an easy one. Okay, next one. Sam sells rubber band holders to businesses that use a lot of rubber bands. And of course, why wouldn't they? She gets paid 15 cents for every sale plus a base weekly salary. So just right off the bat, I'm seeing this 15 cents for every sale. That's a rate. All right, if that's a rate, that means slope. And plus a base weekly salary, well, that's going to be like our initial value. Okay, 1 week she sells 500 holders and rubber band holders and is paid $155, including her base salary. Which equation P, representing pay, and N, representing how many rubber bands has she sold, is correct? Okay, so the pay, what we know so far is pay is equal to this rate right there of 0.15, and that's related to how many rubber bands, right? And in this case here, the question uses the letter N. So 0.15 N plus an initial rate, the base weekly salary. Let's call that S. Okay. So our equation looks like this. P equals 0.15 N plus S. Now, we can use some of the data that's been given to us. So we are given, let's look at the givens we've had here. We have this, we have that, So we're given n equals 500, and pay is equal to 155. So now we can just substitute those in, and we could solve for S. So 155 is equal to 0.15 500 plus S. All right, so now we have to do a little bit of solving. 155 is equal to, so what is it, 75 plus S. Now, we want to get rid of that 75. I'm going to subtract it from both sides. That'll be gone. And 155 minus 75, we'll minus the 5 first, and then we'll minus 50, 120, so we're left with 80 is equal to S. So now we know what that initial salary was. So therefore, our equation should look like this. And we'll go back and see if any of the options is there, and we find that it is. All right. So that was something else we did during this unit as well. So that was solving the equation of a line. If you're given, we're basically given a point, right? Because we're given an x and a y value, and we're given slope, and we just had to solve for the initial value. So we did that as well in lesson like 4.4 or something like that, except this is found in a word problem. All right, so let's do the next one here. Look at the graph below, a line parallel to this one with a lower y-intercept. All right, so it has to have a lower y-intercept and it's parallel. Well, first of all, if it's parallel, that means what? That means the slope is the same. Any parallel line has the same slope. All right, so we need the slope. So let's figure out what the slope is first. We can do it visually. We can do a rise over run situation. I like this point right here. It's a convenient point for us, and this point right there. So we can look at it. We're going up 2 over 3. So therefore, our slope is 2 over 3. So we need to find an equation with the same slope. So let's look at that first of all. Has to be one of these two. We know it's not those. Okay, and actually it can't be the second one because it has a negative slope anyway. But the last part of the hint was the lower y-intercept. That means that this would have to be somewhere down here, right? So the b value would have to be less than 5, which it is. So there's our answer. Okay. The line 2x minus 3y minus 8 would have an x-intercept of, so we want to know the x-intercept. So when we're trying to find any intercept, if you're trying to find the x-intercept, you let the y value be equal to 0. Because if you imagine a graph, right, the x-intercept would be like where it hits here, and that happens when y is equal to 0, because the height is 0. Right? So we need to let x equal 0, or y equal 0, to find the x-intercept. So let's take that equation. 2x minus 3 times 0 minus 8 equals 0. All right, and then we can just start solving this. So 2x we can't do anything about, but negative 3 times 0 is just going to be 0, right? So this is going to just be gone. 2x minus 0 minus 8 equals 0. Well, then we're left with 2x equals 8, and divide by 2, x equals 4. And there's our answer. Now, you could have done a little trial and error if you wanted to, but I generally find that it would be faster to do it this way. Okay, next question. What is the equation of a line that passes through the points -2, 4, and 1, 6? So we want the equation of a line, so we need slope, and we need the y-intercept, because we know it's in the equation of y equals mx plus b. All right, so let's find slope first. So if we're finding slope, we're going to use this formula. M is equal to y2 minus y1 over x2 minus x1. And let's look at our points again. So our points, and I'll go like this. This is going to be my x1, y1. And this will be my x2, y2. All right, so I have 6 subtracted by 4 over 1 subtracted by -2. All right, 6 minus 4 is easy. That's just 2. And then 1 minus -2. So remember, 2 negatives back to back gives us a positive. So it becomes 1 plus 2 is 3. So our slope then is 2 over 3. All right, so next we need to find b. And we do that by inserting either point into the equation. Y equals 2 over 3x plus b. So instead of x and y, we're going to use a point. Now, I don't want to use a negative value because it's annoying, so I'm going to use x2, y2. So y2 is 6, and y1 is 1. All right, so anything times 1 is just going to be itself. So we're left with 6 equals 2/3 plus b. Because 1 times 2/3 is just 2/3. All right, and then I want to get rid of that 2/3. So I will subtract I'm going to subtract the 2/3. And again, whatever I do to one side, I must do to the other side. So I'm left with this. B is equal to -2/3 plus 6. Now I'll sort it out. I'm going to figure it out as a fraction. So I'm going to convert that 6, so it becomes 18 over 3. And that I can solve. So I'm left with 16 over 3 is equal to b. So there's my b value. So therefore my equation would be y equals, and I'll use that bigger pen actually. Erase. Okay. It's being grumpy with me. Oh, I almost erased it. Okay, so we're just going to fill in our values. Y equals 2 over 3 x plus 16 over 3. And there's our answer. All right, come on, baby, don't crash. Everybody still there?
Yep.
Okay. Then it is stuck. Oh, it might be coming back. Okay, here we go. All right. This was the last lesson we did on points of intersection. And this is the idea of linear systems. So we were given two equations, and we had to find where those two equations met. If they are drawn as lines, what coordinates would they meet at? So Alex is writing a question on a test that has his name in it, but it really isn't a word problem at all. It's just a basic test of Alex's ability to find a point of intersection between two lines. What is the point of an intersection between these two lines? So I got one line there, and I got a line right there. All right, so we're going to do this. Now, if you recall, a point of intersection, all we were doing is we're going to let y is equal to y. So basically, y, we're already told that y is equal to this. And then we're told that this y is equal to that, like this whole expression right here, right? So all we're doing is letting those two expressions equal to each other. So we end up with 2x minus 7 is equal to 1/3 x minus 2. All right, let's get all the x's to one side of the equal sign, and we'll get all the non-x's to one other side. So we'll do that right off the bat. So when I do that, that means this and this will cancel out. And I'm going to get rid of that 7. And we're going to add 1 on that side. So we are left with okay, so now we can collect like terms with those x's there. But we have to convert the first one. So if it's out of 3's, we want two full ones. So it's going to be 6/3x minus 1/3x is equal to 5. All right, so now we have 5/3x is equal to 5. Now we want to get rid of this fraction. We have to do it right off the bat. So I want to get rid of this fraction. So if the bottom denominator is 3, I'm going to multiply it by 3. And whatever I do to one side, I must do to the other. So when I do that, these 3's will cancel out, and I'll be left with 5x is equal to 15. Now I want to get rid of the coefficient. So likewise, I will divide both sides by the coefficient. And I get x is equal to 3. So now I have a value for x. This was the first part. So once we have the first part of having a value for x, we insert x into either equation. So I'm going to put x into the first equation. So I get 6 minus 7, y is equal to -1. All right, so there's my y value. Therefore, the point of intersection is at 3 and -1. And there's my answer. Okay, moving on. Let's add one line that's parallel and one line that's perpendicular to the line already on the graph. Well, that's going to be pretty easy. Let's do the parallel one first. So I'll look at the slope first. It looks like it's going up 1/3. So I need to put a line that goes up 1/3. How about I go like here? Up 1/3. There will be a point, and there will be a point. And it'll connect there too. All right, so there's my parallel line, and now I need a perpendicular line. So for perpendicular, remember if that was our slope, our perpendicular slope must be the negative reciprocal. So it's going to be 3 over 1 with a negative, which is the same thing as negative 3. Okay, so I just need to find any point on the graph where I go, let's start right here. And I'm going to go down 3 over 1. Down 3 over 1. All right, so there, and you'll notice that it'll make a right angle right there. So to draw those lines on there, you can't just freehand it. You would have to use slope and show me how you did it. All right, so this is kind of the key. So I can show you that I figured out what the slope was to put on a parallel line, and I used the slope to use the negative reciprocal to put on the perpendicular, and it could go on anywhere on the graph. Like those two lines I put on there are just one of or two different options of like an infinite number of options you could have used. All right, let's try another word problem. So we're going to pick the right plan. So two cell phone plans are available. The first plan follows the equation C equals 1.5D plus 45, where C is the monthly bill in dollars and D is the amount of data used in gigabytes. The second plan is shown on the graph below. Which plan is a better deal for someone who records YouTube videos from his or her phone using over 20 gigabytes of data per month? Well, we could either add the graph. Why don't we do that first? Let's add this onto our graph. So we start off their initial value, which is 45. So we have a B value of 45. So that's going to start approximately right about there. And then it goes up by 1.5. So every time it goes over 1, it goes up 1.5. So let's enter gigabytes. We'll do 5. Let's do a table values actually. That'll be the easiest way to do it. We'll do a table values x, y. So we know that when x is 0, y is 45. What about 5, 10, 15, 20? Let's do that. All right. So we could take our equation, C equals 1.5, and we'll multiply it by 5 plus 45 equals 7.5 plus 45, and we get 52.5. What about if we did it 10 gigabytes? Now, at this point, you may notice that the rate of change is the same, so we can guess that it's changed by 7.5 every 5. So we could just increase it by 7.5, essentially. So when we're at 20, we're going to add another 7.5, and that gets us to 75. All right, so we can put all those points on there now. So at 5, it's kind of like 52.5, which is right around here-ish. And 10 was 60. 15 is 67.5. And 20 was 75. All right, so I feel like I have enough points there to graph this on here. Okay, so this is, and I'll label that equation, C is equal to 1.5 D plus 45. Okay, so the question was, if you're using 20 gigabytes of data per month which one would be the cheaper plan? Well, that should be clear. This one here is the cheaper plan. So by graphing, we can see that after 20 gigabytes, I'm well below that blue line. So therefore, the first plan is the best option. All right, graphing using intercepts. I believe, after this, I'm probably gonna leave the rest for you to do. So this will be the last one. Okay, we're gonna find the X and Y intercept of this line. So just like before, when we have something like this, if we want to find one intercept, like the y-intercept, then we let the opposite equal to 0. So let's start off with finding the x-intercept. So we need to let y equal 0. And it looks like this. 6x minus 30 is equal to 0. 6x equals 30. X equals 5. All right, so to graph that, x equals 5 right there. Now let's do the other one. And this time we're going to let x equal 0. So we get 5y, because 6 times 0 is just 0. 5y minus 30 is equal to 0. 5y equals 30. Divided by 5. Y equals 6. So if we put that second point on, when x equals 0, y equals 6. And now we can graph that. Uh-oh. Where'd it go? Kind of disappeared on me there. Try it again. And there's our line. And I'm going to label it. Okay, so I'm going to let you try the last bunch of them. Bunch more questions in there, kind of similar. And I will put up the test later on today. If not today, then tomorrow morning it should be up by then. All right, any questions?
I had a quick question about the culminating.
Okay, shoot, fire away.
So it's on